Today I'm going to talk about LeetCode question number 200, number of islands. Given an m by n 2D binary grid which represents a map of ones, land, and zeros, water, return the number of islands. An island is surrounded by water and is formed by connecting adjacent lands horizontally or vertically. You may assume all four edges of the grid are all surrounded by water. Okay? So what this last statement means, if we have like land on the border here of the grid, just assume that beyond this grid, this landmass is surrounded by water. So from this entire grid, it's all surrounded by water. Okay. So how can we tell if something is an island? So we can see from this first example here, this is obviously an island. Okay, they're all interconnected ones, interconnected horizontally or vertically, and it's surrounded by water. Oops. And in the second example here, we see here's an island, here's an island, here's an island. Okay. So how do we figure out the number of islands? Well, we can try. What if we try to do this iteratively? Well, if we try, first thing that comes to mind is if we find one, see if it's surrounded by ones, and if it is, then it's part of an island, and then we count that as an island. Or if a one, okay, but then it's hard to keep track of which ones we've already counted as an island. And along with that, what if we find a one that's a part of an island, you know, this bigger island here, and there's a zero next to it? We might accidentally count that as a separate island. So how do we go about this? Iteratively, it's going to be quite difficult, but can we try perhaps recursively traversing this grid? So you can think of this grid as a graph here, okay? And we could perform depth first search on the graph, where every time we encounter a one, we mark it as an island, a visitor island, and we mark all the other adjacent ones as also a visited island. That means we already counted that island in the final result. So for example, we see this one here, we mark it as an island, and then for all other adjacent ones, and those ones as adjacent ones, we mark them as, oh, this is an island that we already counted. So we find this one here, we count it, okay, but we don't want to count, accidentally double count. So for every single, so we spill over. So every single adjacent one, like here, 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 that's horizontally or vertically collected, here, here, we mark that, okay, that's an island. Now let's continue traversing through the grid and see if there are any ones that are unmarked. And if they're unmarked, that means they were not part of this first island that we found. And that counts us as a separate island. Okay, so that's how we're going to go about it. And how do we mark all the land masses that are part of the island? Well, as I said, using depth first search recursively. Just think of this as a graph. So for example, here we see this one, and we mark all adjacent nodes and their adjacent nodes as part of this one island. So here, 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 here. Okay, any other adjacent ones? And this doesn't count because it's diagonally connected, not horizontally or vertically. Okay, no. So we continue traversing, and we found another one that's unmarked. So since this is unmarked, we count this as a new island, and we do the same thing. We check if there are adjacent land masses, and if those adjacent land masses have adjacent land masses, etc. And turns out this one doesn't, so we continue, found a new island. So that's 3, and then again we check all other surrounding land masses that is part of this island, which turns out to be this one. So our final answer is 3. And that's how we're going to go about it. And the time complexity of this is O of n times n, because we have to traverse the entire grid. Okay, now to code this up, so we're going to have a result variable. I just will count the number of islands. Okay, and just to help me out, I'm going to also initialize the number of rows and columns in this grid. So rows 1 grid and total calls equals 1 grid at the first array 0. Okay. Now what we want to do is traverse this grid element by element. Find range total rows for j in the range total calls, and we want to check if grid at this position here equals 1, and this 1 is unmarked. How are we going to mark the ones as already visited, as an island we've already seen? So since this grid only consists of 1s and 0s, we could probably like change this to a new string value like x or 2 or whatever. Okay, so what we're going to do is increment result, that's an island, and then call helper at position I and j. And this will basically recursively visit all the adjacent lands at this landmass and mark them as part of this guy's island. So, and yeah, that's pretty much it for this. And then finally we'll return result. But let's define our helper here. So it takes row and column. And we want to define some base cases. So if row or column are out of bound of the grid, then obviously we don't want to check, or else we'll get index out of range error. So if row less than 0 or column less than 0, then return if row greater than or equal to total rows or column is greater than or equal to total calls, then obviously return that as well. And yeah, I think that's pretty much it for base cases. And now what we want to do in the main body logic is if grid at this row and column is equal to 1, an island, then mark this as visited. Just gonna call this 2, and then we want to recursively search up, down, left, right of it for any connecting adjacent lands. So I'm going to call this helper function 4 times. First time it's going to be to the left of it, second time to the right of it, and third time to the above it, and last time below it. Okay, and it'll recursively call this function. If it hits the base cases, it'll stop execution right there. Otherwise, if it's 1, then we mark it as part of this island, and then for that position, just continue with the recursive calls, checking if there are any adjacent lands to that position there. Okay. And yeah, that's pretty much it there. So I'll try compiling. Oh, it's supposed to be a typo. Okay, and I'll try submitting. Okay, great. Thanks for watching.